Railway Conversations with Doc Frank.
Hello and welcome to Railway Conversations with Doc Frank. I'm your host of this podcast, Doc Frank, and my guest today is Artur Wolnica from Katowice in Poland. Artur is a very experienced professional in the area of ETCS testing. He has done tests on a number of different ETCS projects in different European countries, including, of course, Poland, but also Germany, the Netherlands, and Belgium, just to name a few. And anybody who wants to know about testing of complex modern signaling systems such as ETCS will certainly have a blast at this episode. I hope you enjoy. As you know by now, this podcast is not sponsored by third parties, but I do want to let you know that I'm offering training courses on CBTC and ETCS. They're called Kickstarter courses because they really produce a kickstart for any participant to build up the knowledge of these technologies, either CBTC or ETCS, from scratch. And this is regardless of your previous knowledge of signaling. Yes, you heard that right. The courses are structured so that even complete beginners in signaling can benefit from those courses and will understand everything that is being taught there. These courses can be accessed on my training portal, which is docfranktraining.podia.com. I repeat, docfranktraining, one word, .podia, Podia.com. I hope to see you at one of these training courses, and until then, please enjoy my conversation with Artur Wolnica. Artur, welcome to the show.
Hello, Frank. Nice to meet you.
It's good that we finally meet in person. We've been connected on LinkedIn for a while. And from what I could see from your profile, you haven't always worked in the railway industry, haven't you? How did you get into railways?
Yes, you are right. So initially I didn't have any railway background. So because I graduated from the computer science, which isn't really related to the railway engineering. And initially I was looking for some opportunities in the engineering area, and luckily there was a company nearby which was looking for some ETCS engineer. And even though I didn't know much about this role because of my previous experience, which was known, I applied for it. And then I initially was invited for the interview. And the funny thing was that one day before the interview, I was trying to get more information about the ETCS itself. And because it was back in 2013, there wasn't really a lot of information available. And so the main source of the information was the Wikipedia at that time. So what I did, I just went through the Wikipedia and read a little bit about that. And then the next day I was a little bit ready for the interview. And, this was, I think, the first important thing was that the opportunity was there, and I was also at this time looking for something. And then I decided, okay, from the offer, it looks very interesting, and also considering the aspect that the role and the ETCS is about to be integrated within many trains or the railway systems. That meant that I will probably be part of something big. So that was my initial thinking behind that. But that was the first part. I think there were also some other parts. So the second important thing is that initially when I started in the company, I was immediately exposed to the system itself. So I didn't need to read the specification and try to visualize things, because I had already the system more or less on my table, where I could have seen the hardware, software, the configuration, parameters, a lot of cablings going on, applications running. So it was a real pure engineering at that time. So for me, either if this would be a railway system or not railway, it wouldn't really matter at that time, because it was a pure engineering, which was very interesting. On the other hand, I had also the requirements besides. So when I was trying to figure out how the system operates and functions itself, I had the requirements with which I could check if what I understand is correct, and also the opposite. If I had the requirements, I could have checked if I understand the requirements correctly, because I had the onboard system on my table. So initially I did a lot of self-work also, because I spent a lot of time in the lab doing the tests of the system, just to understand it, just to find out what is behind that and try to figure out what's going on. And then I think this was very important aspect, that I was initially had it and I could play around with this. But what is also important, I think, that I was able to find there were also right people who introduced me into this railway engineering career. And it's probably the most important factor, because if the people were not there, may have been discouraged, for example, and it may have ended up very quickly. But because I met very good people who were very supportive, who gave me a lot of feedback, a lot of trainings, who spent a lot of time for me, I was very happy that they played a very big role in my development. And if not for those people, then I would say that I wouldn't be where I am right now, because simply I would probably switch if that would not be in my interest. So I think these are the certain points that happened. And of course, there was this little bit of a luck as well, that there was some opportunity. But what's important is, even when you don't have this railway background, you still can learn a lot. And this is not mandatory constraint or condition that qualifies you to be a railway engineer in the future. So I think you should, or people should not be discouraged if they want to grow in the railway engineering, that they don't have enough experience, because experience is not something required when you just start. Over time, you build up the experience that you will use in the project, or you will see whether this path is something for you. But initially, it's not something that is mandatory to join this area.
Interesting. There are a couple of things that come to my mind when I listen to you. So number one is that when you enter the railway industry, and specifically the signaling industry, it's not like you have to start with the very basic signaling one-on-one, and then it needs to take, 5 years, 10 years or so until you get to the more sophisticated technologies such as ETCS and CBTC. I mean, I had a podcast guest before which went straight into CBTC, started their career with CBTC, where everybody says, oh, this is such a complicated technology. In your case with ETCS, people would probably say similar things, and yet there you are going into the rail industry and starting straight away with one of the more sophisticated technologies. So that works. Observation number two is railways is an interesting industry with a lot of potential. There's a lot of work going on. It's a lot of career opportunities. And it is attractive for people from other industries, as long as they are encouraged to stay with it. And that's basically point number three, where you said you had several people when you started in the industry, probably more senior people with more experience, that were happy to share the knowledge with you, to also motivate you, to basically make it attractive for you to stay in the industry and to find your career in the industry. And that leads back to something that I keep saying all the time whenever I'm asked, how can you address the shortage of resources in the rail industry, where I'm saying it's got to be a mix of the more experienced engineers and young people that come into the industry, maybe because they are graduates coming from university, or there are some younger talents that just want to migrate into the technology, which are just curious, and the young people normally they are into more high tech, into more sophisticated technologies. And if we can create a mix where the senior people are really willing to mentor the younger ones and to give them their knowledge, to share their knowledge, then it really helps the younger ones to grow into the industry. And I think in your case, that has ended up quite successful.
Right, exactly, Frank. That's all the 3 points that you just mentioned. I could relate to them, because my injection into the ETCS, where I just started, like even from day one, I could have play around with the system. I had it. And even without the proper knowledge and the background, it didn't play a big role there, because it was my own interest that, okay, I have some engineering, devices here or some hardware, software, where I have to check how something works and I have to investigate a lot of things. And I think this jump into a little bit big water was very interesting on one hand side, but also very good because that's even without this prior experience, you can just feel it. What is it all about? You can just get a glimpse of this whole system. Of course, you get a more exposure after you see it in the operation, for example, in the vehicle. But first initial one, when you have a test center or the test lab where you can just do whatever you want, it's like a safe environment. And you have a lot of colleagues around you who are senior, who give their time for you, who give you the materials. And this is like an investment in like beneficial for both sides, because you benefit as a person who has just joined, and the other person also benefits, or the company benefits, because the company is growing up, the new talents or the new people, the new resources that may stay for a longer period of time. And of course, it's also about the person, him or herself, because you either have this willingness to learn, or you just want to stay aside and just don't want to do much. So it's always this personal interest also. And in my case, I was always interested in taking up the new challenges. So that means that whenever there was any opportunity to check something or to jump into a new topic, I was always ready, I would say, just to be thrown away and then thrown into the big water and then see if I will handle that. Because of this, I think attitude, it also plays quite a big role here, especially ETCS is a safety system. So you have to have a lot of, you need to be always maybe, you have to always have this willing to learn, because there's a lot of information that you have to proceed. And initially you don't have this information. After a while, you just reread some documents or just the principles, the specifications. And for me, myself, actually, it happened even 5, 6, 7 years after I started that I just took on a business trip a lot of papers, specifications that I started with initially. And I did a lot of like highlights or some notes. And it was like a solidifying of my knowledge that I collected initially. And then I was maybe thinking over some topics that were not understandable in the beginning for me. And then over time, in the next few years, when I went back to these topics or these principles for the ETCS, it was more clear for me. And sometimes even I discovered new things and which I was not aware before. And also that's important because all the systems are evolving. ETCS is evolving. We have a lot of different baselines, a lot of different versions of the system, where if you just stick to one version, which was initially there 10 years ago, then after a while you will be not up to date. And then you may face up some situations when you are doing something and then you expect something else that should happen, that normally should happen because of the new version of the specification, for example. So this constant learning is also some important factor that over time you or someone should develop in order to be always upfront to the new challenges that are coming.
Yeah, I can imagine that, especially in your case, constant learning is an important aspect. I mean, it's probably in everybody's career an important aspect. But if I look at your career, you've basically stuck with ETCS throughout your Revit career, as far as I could see. But you worked in different countries. You worked on different products from different suppliers. So I think you've seen quite a variety of ETCS, and you're probably quite well positioned to give a few, I don't know, more general comments about ETCS in Europe, how the whole thing is going, what kind of observations you made. I mean, obviously focus on the verification and validation aspect that you are specialized in, but I'm curious whether you would be willing to say something more general, like an assessment how you think ETCS has been going in Europe.
Okay, so that's quite a broad topic, to be honest, and there is a lot of different aspects of the ETCS, because ETCS itself is comprises of different levels. So we have a vehicle, we have a trackside, we have the interlocking or the GSMR network. So all the systems have to work together. If we talk about the ETCS, we have to consider many different systems, and all of them have to talk to each other. And of course, the main goal of the ETCS is to bring the sustainability and the operationability, and also the, let's say, interoperability of the trains in the whole Europe, which is not only the Europe actually, but the Europe is the place where the ETCS was developed. So this is the very big playground, I would say, considering how many countries we have here and how many national systems are there. Because then Europe, I think it's more than 20 national systems that are operating in Europe. Yeah. So when we talk about the ETCS, we have to consider that if this is going to be a system that will replace all the legacy systems that are there, it will not happen in a very quick time. So there is a lot of things that needs to be considered for each country separately, because initially, like every country had its own legacy system. Therefore, every country had its own sets of specifications that had to be fulfilled in the past. And since the ETCS has been implemented in the whole Europe, the idea is to keep away the legacy systems and just to keep the ETCS. And that is not easy, because you have to consider the differences in the infrastructure in different countries. So it may be that the infrastructure in Germany has a different capabilities or different specification than the one in the Netherlands, or the one in the Netherlands can have different suppliers or different provider than the one in the Switzerland. And it goes farther, because even certain lines that are in certain countries have different specifications. And as a base example here, I can also refer maybe to the Dutch project where I initially started in, and therefore back in 2013-14, there were like 5 ETCS lines, and there were a lot of differences between them, because you have either the pure ETCS level 1 or level 2, or you had a mixed signaling where you had ETCS combined with the national system as an overlay. And therefore, you also had the ETCS system line, which was level 1 and level 2. So that means that you couldn't really run all the tests the same in all of those lines, because there were differences. So if you want to have your system authorized for this country, you either had to do a lot of tests in the field. And at the time, I remember there were 450 tests that you had to perform to get the authorization for the Netherlands, which is quite a huge, concerning that the field tests are very difficult in operation and to preparation, because it takes a lot of effort for the manufacturer of the system, as well as for all the stakeholders and all the people that are involved to organize them. And also the cost aspect is very difficult. That's very important here. So imagine if you had to perform 450 tests in the field when you have only limited access to the track. Sometimes you are not allowed to be on the track during the day, because it's not, because there is a commercial operation, passenger trains running. So in this case, a kind of a unification is also needed for the ETCS. But what I can see from the perspective is that there is a big improvement done over the last 10 years in Europe. And even some countries, they have introduced ETCS on the whole network. And here as an example, I can provide the Luxembourg, which is I think it's probably one of the first country in the Europe that has already implemented ETCS over the whole network infrastructure. Although Luxembourg is not a very big country, that doesn't, let's say, discourage them from implementing the level 1 system. And there is no legacy system. So every supplier has to use the ETCS onboard unit of the vehicle, and also has to fulfill the specification. And in terms of this specification or the aspects of this interoperability, the European Union or European Railway Agency is acting very actively into unifying the test standards that have to be passed in order to get the authorization. So since several years, we have the ESC standard, which is implemented in some European countries already. So this is a set of specification that is clear, that is authorized by the European Railway Agency. And with this set of specification, you or the provider of the system or the subsystem knows what has to be performed. And there are several ways how it can be achieved. So of course, the field test is ultimately the part that cannot be, in my opinion, skipped in the authorization process or in verification, validation. But there is also another way how it can be done without being in the field. And here comes the interoperability in place, because we have there is a couple of test centers in Europe where you can just take our system, either onboard or wayside or interlocking, GSMR, RBC, whatever. Then you keep it in the lab, and then you have the same infrastructure is in the lab that in the field. And because of that, you can do a lot of tests in this closed environment, safe environment, without disturbing the railway operation somewhere in the field. And there is a lot of positive aspects of this, because first one, of course, you can save a lot of time by the preparation. Secondly, you can do more in less time, because you don't need the vehicle. You just have your system. You just confront it against some other supplier systems. And that is one point which is, I think also the awareness is growing in Europe that such test centers is really needed in order to implement the system quite faster, or do a lot of things in a faster way than just rather doing everything in the field.
Yeah, you know, the thing with ETCS is that I would say at least 95% of the cases, ETCS will be implemented on an existing railway, will be overlaid on an existing railway system, either by replacing the old system for automatic train protection that is there in a certain country, or by supplementing it for migration phase where the old system will be switched off later. But you, in almost all cases, you have an existing operational railway, and of course this railway needs to be kept running. So you can't just come in there and say, well, I need 6 months for my field test. Let's just shut down the railway for 6 months. This is not happening, because you interrupt the supply chains for freight trains. You interrupt the passenger services on the rail, and passengers get frustrated. They're looking for alternative ways of transport, and they may never come back to the railways. So the disruption of an existing railway by shutdowns, I think, needs to be minimized, if not completely avoided. So, and there are certain ways how you can do that. I mean, you can do tests during the night. It may be at the end of the day that not all the field tests can be avoided. Yeah, you can try to minimize it by maximizing what you can test in a test lab, for example. But there may always be some kind of residual field test that you need to do, but this is then hopefully something that can be done in a very short period of time, or maybe even during the night, during non-service hours, so that at the end of the day, when you really bring your ETCS into operation, it basically just you switch over and you don't switch back. Yeah. I think in other technologies, CBTC, for example, it's meanwhile best practice that you have an over and back testing mechanism where you run the railway with the old system during the day, and at night you switch over to the new system, and in the morning then you switch back to the old system to keep the railway running for the next day. And you do this back and forth pretty much as long as you need to have all your tests done and to make the operator comfortable that the system works and that's safe to sign the system into service. And then when it gets to it at the very end, you basically cut over to the new system, and then you just don't cut back, you just stay with the new system. So that's at least the theory, but it would be interesting what your views are, to what extent this is already achieved maybe with some railways, or to what extent you think it may be achievable in the near future? Maybe because test procedures become better, maybe because the test labs are getting more sophisticated. So pretty interested to get your views on that.
Yeah, of course. I could relate to also one important point that you mentioned, that you cannot really simply switch off the line from the operation. There is a passenger services running, and of course there are certain lines where you can access during the day with a vehicle, but you may always be exposed to some problems, because if you cause a problem on the real operation line, then you cause a real delay to the passenger trains. And in fact, this also happened in the past in some of the tests where I attended, that because we did some test runs, and of course with a system that was not yet authorized, we may have expected some issues or failures, and therefore some risk is always there that the passenger service will be affected. So also, as you mentioned, one of the possibilities that is used already during the field test is that the lines are used during the night, mostly for the tests, but that also brings a limitation, because if you have a lot of suppliers that want to test their systems, and you got only this short period of time where you can do the test, that makes it that there is a real queue for the access to this railway networks. And you have to plan in advance, sometimes within the weeks or even months, some test runs in the field if you want to really get your system authorized. And then if you just, if you miss the slot or if something happens, then you need to plan again. And this makes it very complicated. In Switzerland or in the Netherlands, you can only test during the weekends and during the night. So that's also many more constraints is there, because you cannot simply go whenever you want. And that's why it's very difficult. And also during the night, you only have a limited amount of time. So usually that's when the last passenger train leaves the track. And so, for example, from 1 o'clock until 5 o'clock, you get a time period when you can do the tests, but it's only about maybe 4 or 5 hours, nothing more. And as soon as you get to the 5 o'clock, you have to leave the track. Otherwise, you will cause the delay of the first train, which may interfere with the next train. So that's a very, very, very complicated. Even in terms of the planning of test plans, you have to plan a certain amount of tests for the night. If you get only limited time of the test, like 5 hours, you have to plan your tests in a very detailed way. There is no space for having any, sometimes you can plan some retests, but normally if you test according to the schedule, you cannot go outside of the schedule, because you may be overtime or you may cause some delays. So that is a lot of things that is playing a lot of big role here. But I think that what can be done, and as also mentioned before, as that part of the test can be done, I hope in the future the field test will be replaced partly by the equivalent test that can be done in the lab with the same infrastructure. The infrastructure must be the same as the one on the track where you are going to have your authorization. That is very important. So the supplier of the track side has to ensure that it's in line with the one that is run on the track. That is definitely the first case. But also, there must be some general rules that allows to do so. That has to be approved by for example, the European Railway Agency. That more labs should appear, because that will save a lot of time, a lot of effort. And in the Netherlands, for example, you can do this, and you can actually test. Back then, I think around 2016, 15, 16, there's been, you may have already tested completely 2 ETCS lines in the lab without going to the field, which was the equivalent of the field test, because you did the test on the same infrastructure. And that was it reduced the number of tests by 200. So out from 450 that you had initially had to pass, then you got only maybe like 250, which reduces the effort for the test by half. And I can imagine that if more test centers like this exist in the future, then also it would be easier for the supplier of the systems just to authorize them without waiting for so long to get access to the track. And also the cost of the introduction of the system would also be lower, just also for the customer, because in the end we have to also think that the end customer will have to pay for the system.
Yeah.
And if the authorization process takes so much time because of the access, for example, to the network, then there are certain speed up actions that can be taken place here. And there is, I think, a lot of room for such activities, and that would for sure make the implementation of DTCS much more efficient.
I could also imagine that that countries want to have their own test centers, their own test labs. I'm just imagining if you're doing an ETCS project in Poland, and the test center for ETCS is in Spain, which is entirely diagonally the other end of Europe. I could imagine if the people in Poland have an issue sending the technology over to Spain, they will find it difficult to travel there to witness a test, or only, I don't know, 1 or 2 people can go. And then the question is everything correct? Did they really satisfy themselves that all the tests were in order? Yes, there will be test reports and there will be signed and everything, but still, I believe there is still a remaining level of, I wouldn't want to say mistrust, but maybe uncertainty, where they say, well, if the test lab was in our own country where we can send, I don't know, dozens of our own engineers to witness the test, to check that everything is right, to stay with the test the entire time because they don't have to fly out to Spain or Belgium or wherever the test centers are. I could imagine that could be a big drive. That basically confirms what you just said, Lars, that if you had more test centers, that would help the entire process. And that probably wouldn't mean like you have one test center in Spain and you build 3 other test centers in Spain right next to it. That would probably rather mean you have one test center in Italy and one in France and one in Germany and one in Poland and one in Denmark and so on.
Yeah, of course. I agree that there is this. Maybe it's possible that you could have these test centers within the countries, because also there are certain specifications for the country. So, for instance, if you would need to play the test for Poland in Spain, of course there must be people in Spain that would need to know what is behind the test spec that is valid for the Poland, for example. It's not that obvious, right? Maybe the test could be obvious if they come from the standard, but still you need to have these people who are skilled into performing those tests there. There's also this aspect, which is quite important actually, about the being confidential. So if you shipped over your test station somewhere else, it's and you ship it basically to some other company who has their own systems, and you always should have someone who is there. If you just leave it's basically not a good idea. So that because of this confidential things. So basically what I can imagine, or at least how it works right now, is that you have only a couple of centers where you just need to ship over your test station where you do the test. Of course, you should be there physically because you know it, your system, and you are responsible for it. You are also have to know what you are going to test on which line. So that's why this human factor is important. But what I can imagine in the future is that if each country has its own test center, and if this would be approved on the European level, then it would be much easier, and also it would be much more efficient. And I think also for the workforce, of course, naturally, the people who would be responsible for his or her project in the certain country would have the biggest knowledge about what needs to be done in order to have the system authorized. So, of course, now the knowledge is usually within the supplier of the system. So if we are about to test, let's say, the system that we want to approve in many different countries, that we also, or the company who is the supplier of the system, needs to know the principles, what is going to be tested. But in the end, I think there is a lot of things that can be done on the European level to make it more efficient. And in Poland, actually, I remember there was also discussion even started last year about the creation of the test center that can be used in this case. And not only for, let's say, internal purposes of the company who is developing the system, but also for the whole other suppliers who would like to do the tests, but they do not necessarily want to go to the field and spend so much time and effort. Yeah. So the idea is there. It's only, I think, that there must be this kind of a cooperation between the entities and in the end agreement on the national level and also probably on the European level that, okay, we have this test center here and now all the suppliers from the whole Europe who want to have their systems operated in Poland, for example, they will come to the lab and they will have this test specification coming from the European standard. So there will be no discussion about what needs to be tested. Because in the past, or in some countries where there was no standard rules about how to proceed, there is still a lot of discussion even to find out what is behind the test. Okay, what we should really test? We have a lot of different test specifications and they are not unified. They are not provided by the European agency. Therefore, the national authorities are usually responsible for providing the most valid specification. But of course, this also should be, somehow tracked, because there's a lot of different versions of the baselines of the systems, for example. And for me personally, it also happened that when I was doing some tests in some country, there were some authorities or the assessment body who was performing the test of the system, and somehow they did not use the correct specification, or the test specification was related to the previous version of the generic requirements for the ETCS. And this kind of things are quite important because you always need to know what you are testing. And this information, either or you may do some test runs in a wrong way. And in the end, what is the results? You may have the results which have no sense or no value at all because you are doing something according not to the latest release of the baseline, for example. So there is also a lot of things behind when it comes to definition, what really should be tested. And when it's defined on the European level, there is no discussion. So you just know the baseline, you have everything that is needed, but then it's coordinated. But when it's not coordinated, there may be the cases where you just end up with some wrong assumptions.
Hello, this is Doc Frank again. Before we get into the second part of this podcast episode, I want to let you know firsthand of something that's really, really important to me and which will be a real game changer in the signaling industry. If you listen to the podcast so far, I assume that you have an interest in communications-based train control or CBTC. And if you do have such an interest, you will absolutely love the virtual conference that I'm doing on the topic of CBTC. It is called CBTC World Summit 2023. It's an international event with 3 different sessions, one for the Asia Pacific region, another one for the Americas, North and South, and the third one for Europe and the Middle East. These sessions of 6 hours each, so in total 18 hours of conference content, will be held at different times of the day according to the specific time zones. And the good thing about it, that you as a participant of this conference will have access to all of the sessions without skipping on your night's sleep, because all of the sessions will be recorded and will be available for you as replays. So if there are any parts of the conference that you cannot attend because of problems with the time of day, you have always the possibility to get back to the recordings and watch it at whatever time you like. There's a price to the conference, but it's relatively cheap compared to other conferences with much lower reach. So for a global conference of CBTC, it's a relatively inexpensive conference, and it's really, I believe it's a world first, actually. I don't think that anything like this has ever been done before, that a CBTC conference really takes speakers from all over the world and offers them in different time zones for everybody to attend without having to travel to the conference venue. You can register for this conference on my training portal, docfranktraining.podia.com/summit23. I say that again, it's docfranktraining.podia.com/summit23. I would be delighted to see you as a guest at the conference. And now please enjoy the second part of my conversation. I think this leads over to the whole topic of interoperability. How I understood the last thing that you said is that there is a certain risk that different countries go into different directions. You mentioned differences between baselines, different version of the system. I mean, the baselines is a relatively recent invention in ETCS, where people were just trying to reduce the number of different versions of the system. Yeah, previously, when I was still in Europe, there was a whole raft of different versions, until then one day basically everything that wasn't baseline 3 was bundled together into baseline 2, and that was it. And then everything older than baseline 3 was just baseline 2. And I think of an example in the Netherlands, for example, where they had the first 3 ETCS projects, which were done in different parts of the country on different lines by different suppliers at different points in time, which means on the basis of different software versions. And there was initially no interoperability need because all the lines were separate from each other. But then suddenly, when they were starting to run trains on several of these ETCS projects, they realized that those projects were all not interoperable for a variety of reasons. So they now basically need to go through an upgrade of every one of those projects to basically bring them all together, bring them all to the same status. In your case, and this is just within one country, in your case, it's even more extreme because you've worked on ETCS projects in different countries, in Poland, I think in Germany as well. How do you see where the industry stands with regards to real interoperability in Europe, and to what extent there still is a big risk that different railways basically have different interpretations of the standards, have country-specific features and functionalities, where there is the danger that the applications of ETCS just go off in different directions. And when you really want to have one train going from one country to the other country to the other country, then interoperability may not be as good as people thought it would be from ETCS. Do you have a view on that?
Right. So, yeah, I think that it's relatively maybe easy to coordinate the interoperability within one country, I think relatively, but it's also not always, because different lines have also different, let's say, systems implemented by different suppliers. So if we talk about each separate country, I think it's important first to understand between the suppliers that the requirements for the system have to be understandable. which means that if there is a supplier for the GSMR network, and if the line contains of different suppliers, then okay, one part of the line can understand the requirements in other way than the supplier of the second part of the line. That is very important. On this, just on the requirements level, they have to be very clear and they have to be really understandable for all the parties, because sometimes the lines are equipped even with the 2 or 3 manufacturers or the suppliers. That therefore, if there is a mismatch in understanding given, that we end up with the no interoperability, because in the end it will not work in the field or nowhere. And so this understanding of the requirements is very, very important. Then I think of course there must be also understanding about the some correspondence between the requirements for the GSMR and also for the track side and also for the vehicle, because all of them have to come together in the end. And this, especially on the lines where there is a mixed infrastructure from different suppliers and also from different vehicle suppliers of the onboard systems, they have to all know which type of system have to be implemented and in a concise and understandable way. And therefore, I think one of the points that plays a role here, and also from my personal experience, I did some interoperability tests in some test centers in Europe, when on this level, without going to the field, we found out that there were a mismatch in interpretation of some requirements. Even though they were standard ones that had to be obeyed by everyone, every supplier, there were still some cases where it was not really clear about some certain technical aspects. So one supplier understood it in one way, the other supplier understood it in another way. So in the end, they did not match. But because we were on the lab level, or we didn't go into the operation yet, that also saved a lot of time in the end, because it was discovered relatively on the let's say in the middle of the project, so there was no problem in let's say modification of part of the system. But if this would have happened later during the operation or during the field test, then we would need to go back to the stage of the development, and of course this would take a lot of effort, costs, time for just making it up and running again. Yeah. That's why it's very important. Yeah. Here is only the aspect about the interoperability within one country, but we also have this broader aspect of the interoperability as a whole between all the countries. And here is also, at least I've got a really good example for this case, because we did a lot of test runs in the past between the Netherlands and Belgium. We had a project that for the passenger line from Amsterdam to Brussels. It was back in 2017. And I remember it very well, because it was like every weekend I was in Amsterdam where we started, and we did a lot of test runs over the border. And it's been a very extensive test campaign for several weeks or even months. And the interoperability there was very difficult, because you had to fulfill the requirements coming from the Netherlands on the one hand side. Yeah. You had the Netherlands, on the other one you had Belgium, which had different sets of requirements. So you actually needed to fulfill everything from the Dutch side and everything from the Netherlands side. But there were also differences in the implementation of some certain aspects. For example, the GSMR network had slightly different requirements on one side of the country than on the other one. And that meant that also within the ETCS system that were used on the vehicle, it also had to obey 2 conditions, I would say, one from this country and the other one from the other country, which was very difficult to achieve, considering that the border of the countries were, let's say, also in the GSMR network, were like an overlay. There was like in Hanover, and a lot of information was exchanged within the system itself. Therefore, these differences costed very make it very difficult to find the right solution in the end. And we spend a lot of time there just to find out what is the best configuration that can be used there. So on this European level or on the country level, interoperability plays very important role because that's the basic principle of the ETCS. We want to start in Portugal, I want to go to Norway, for example. And this can be achieved, of course, but there is interoperability plays the crucial role here. Without this, it will never be possible.
Yeah. So yeah, and again, I think testing is very important. So what I really want our listeners to take away from here is what I keep preaching in my LinkedIn post, what I keep preaching in my training courses on ETCS as well. Number one, interoperability for ETCS cannot be taken for granted. Yeah, so you have to make sure that everybody involved understands the requirement in the same way. Ideally, you would want to have some kind of a test bench that represents the requirements and which can be used for testing all the different components from different suppliers against it, the RBCs, the onboard systems, and so on. And the second important aspect here, and you did mention that before, is that the earlier you get into tests, the earlier you can check whether the suppliers really meet the requirements. I mean, they will say, yes, we meet the requirements. Yes, this is as per the standard. But then as you said, if suppliers interpret the standards in different ways, they may implement it as they understand the standards, but it's still a different implementation than the other supplier does with a different interpretation of the standards. So the earlier you get into some kind of testing that will flush out those differences, the more time you've left until the end of your project to rectify something, to really sort out with the suppliers, wait a minute, there's a difference here. Why is this and how can we get it sorted? And when you still have 2 years until the project comes to an end, then you have a fair chance to rectify something. If you have only 2 days until the railway is supposed to get into operation, then you're stuffed. You have no chance, and you will have a schedule overrun, and you will have additional costs and all these kinds of nasty things. So I believe that thinking right from the start of a project, what needs to be done to get to interoperability and how it can be made certain along the way of the project that the suppliers are really going into the right direction. If it turns out they are going into the wrong direction in some aspects, they can be taken back on track and brought onto the right direction. I think that's very, very critical. Yeah. So that's not to say people give up on ETCS and interoperability because it's also terribly difficult. This is just to say, don't underestimate this. If you put in the work, if you think about clarifying the requirements, making sure that all the suppliers have understand the requirements in a coherent way, making sure that you've got your test steps along the way to make sure that following the path through the projects, the suppliers are really doing what you expect them to do. Not just what they contracted to do, but what you expected to do, which means that they implement the things in the same way as you expect them to work, so that the interpretations are the same. If you do all those things, then with ETCS, you do have a fair chance to end up with something interoperable. Whereas if you look at other technologies such as CBTC, where every product is proprietary, you can do whatever you like. You will never get to an interoperable outcome. So there, the benefit of ETCS certainly is, as I call it, the potential for interoperability. That the specifications give you an avenue where you can get to interoperability, even though you have different suppliers and different country applications and so on. But you still have to put in the work. You still have to make sure that the implementation will really be in the way that you expected it to be, that will lead to an interoperable outcome.
Yeah. Right. Yeah, I agree completely, Frank. Important also thing that came to my mind just is that, for example, I think like you may in your own lab, if you have just your own lab, because I believe all the suppliers have their own labs, it is also my impression is it's not possible that you always test all the conditions that can happen in the field. And that's why I think it's important to have this kind of a interoperability labs where you could test these certain situations to be sure that you can always rely on the latest data that is coming from the track, because you can do a lot of tests internally, like engineering tests for yourselves within the suppliers will do them most likely, but to be sure that you are still referring to your input information for the system is always updated. You should have the access also to this information, because you may do the test on the limited amount of data and maybe you will miss some point that has changed over time in the track side, which may cause in the end that, okay, you did a test runs, like you did your own test in the lab, but in the end it could be that, okay, but you didn't test against the latest version of configurations of the track. So that is important also, that even those engineering tests that are done on the subsystem or the system level within the suppliers themselves, they will probably never cover all the cases. They will never be as reliable as the official tests that are to be performed in these test centers, where you have the real operational data from different suppliers, I think.
I'm a bit conscious of the time. That's such an interesting topic that we keep running, and we're almost there for an hour. Before we close, there's one thing that I find relatively important that I don't think we have touched on yet, and this is the whole topic of test tools. I'm not really sure whether the suppliers of ETCS are optimally placed to provide test tools. I mean, every supplier will have certain test tools to basically test their own system. So they program their releases, for example, and then they will have some kind of test tools to make sure that the programming of the releases was correct. And the same for their onboard systems, for the DMI, and which is the driver machine interface for those of the listeners who don't know, and so on. But this is like in a silo. So the one supplier has it here, the other supplier has it over there. And when it comes to things like interoperability, like bringing those suppliers together, the tools of each supplier will really not do the job. So there are a few suppliers out there in the field, not very many, who have specialized on test tools for ETCS. So one that comes to mind is Multitel from Belgium. And I believe what they're trying to do is to basically help the buildup of test centers and also create tools that make it replicable. That basically means they have a set of tools where they say, okay, well, if I have this tool and this tool and this tool and bring these tools to, say, Poland, that would help the people in Poland to build up their own test center for certain purposes. Like if you say, I want to do an RVC test, I want to do an onboard test, I want to do an interoperability test between two different RVCs, then it basically comes down to a set of tools which you can use to build a test center like this. Have you had any experience with those test tools that were not specific to an ETCS supplier? And to what extent would that work? To what extent would that help?
I think that, as you mentioned, the suppliers themselves, they have usually their own test tools, which they're using for the simulation. And it's usually, from my experience, just internal, some R&D or some development or some test tools based on many different previous versions, which are being updated constantly, endlessly, I would say. The test tools that I was only not personally using, but that I was aware of was but they were the test tools used from it's called the environment, the ERTMS camcorder, but these were more the tests that were the tools that were used during the test. It was just to record all the information that was coming from the track side, and also to make the videos, for example, and to synchronize, for instance, the video with the passage of the balises. There was a recording of the data also coming from the GSMR. So all this tool allowed to synchronize all together, because instead of maybe running through a lot of data from different sources, which also are part from the ETCS, there is a lot of different information. Sometimes they are internal, sometimes this is a GSMR or the like infrastructure like balises. Then this camcorder, as far as I remembered, it was used for the assessment company who used it for their purposes, just to synchronize, to keep everything together. But up to now, I think I have not been involved in any kind of activities where such tool would be used at the end supplier. So, for instance, the end supplier can buy this tool, for example, for the lab purposes. At least I'm not aware of this lab environment tools that can be used as a unified tool set for testing internally, for doing the engineering tests by the suppliers themselves. But for the field, that's the only one where I was a little bit when I saw that something is going on with this camcorder.
Yeah. Okay. Well, yeah. I mean, the test centers, and there are more test centers, I think, coming into service. I mean, of course, there's the very famous TEDx in Spain that has been around, I don't know, forever. That was already there when I was still in Europe, and that's a long time ago. And by now, I think there's another test center in Belgium. I think test center has been built in Great Britain. And I'm not sure that there may be a few other ones as well. So and the thing is, creating a test center from scratch, where you really have to basically start at zero and try to implement the entire ETCS functionality into a new piece of software and computer hardware, is an immensely onerous exercise. Yeah, so if you have certain standard tools, say for example a test bench for radio block centers, which has already implemented the relevant parts of the ETCS standards, then this is something which I think would be reusable because you've got a piece of hardware and you can build more pieces of the same hardware, and then you've got a piece of software that you can multiply on different computers. So you basically can recreate the same RBC test bench for several applications, and then can basically spread it out into different countries for building test centers there. And then I think the effort really comes down, instead of building something up from scratch, from zero, basically already having an existing functionality of your test bench, and then basically just customizing that existing functionality to make it specific to the test center in the respective countries.
I think maybe one crucial point here is that to really bring up this interoperability, I think the initial plans for the development of the ETCS should harmonize the new lines that will come into the operation with the same standards or with the same principles. It should not be really much differentiated between the lines. Okay, here we will use these functionalities, but on the other lines we will use completely different, because this makes things more complicated. Harmonization, I think, also for the planning, of course, for the next 10, 15, 20 years is very important on the European level to bring all the same page.
And I have the impression that the Europeans have understood this. So over the years, I have followed several conferences on ETCS, which happened in Europe. Some of them were virtual, so you could basically watch it on your computer screen, what was told there, and you saw the presentations and so on. And I think a few years ago, there was a real turnaround where people said, well, look, we've got problems here with the ETCS rollout in Europe. It takes much longer than everybody thought. There are interoperability problems left, right, and center. So there's not a single project that really goes into service and boom, and everything works. And it's much too expensive. That's obviously the operator's view, the view of the railway organizations. The suppliers say, no, it's not expensive enough because we don't generate enough revenue to compensate for all our R&D expenses and so on. So there were some fundamental problems. And I think one key problem that was identified at the time was this whole thing of normatization that you mentioned, where you basically see for every baseline, every new baseline, it says reasons for upgrade, and one of the reasons is always debugging, right? There was this famous version 230D, and the D stood for debugging. And debugging in the ETCS language basically means identifying differences in the interpretations and trying to bring it together, trying to make it coherent. This is what they call debugging, right? But then you see that with every new baseline, it's debugging again, and you're just wondering, when does this stop? And I think this normatization is really the attempt to stop it once and for all, to basically have a golden template for ETCS functionality as per the standard, where you basically have a model which explains practically, functionally, not just written with words on a piece of paper. This is how it should function. This is how it should work. So this is your golden test bench, and anybody who's bringing along an onboard system working on this test bench, anything that goes wrong is a problem of the onboard system, because the test bench is untouchable. That's the gold standard. This is how it should be. Yeah. And but getting there is certainly a difficult thing, and I could imagine that would also cause problems with any suppliers that do not fully align with this gold standard, where they say they have to change something, where they say no, but our understanding is correct and this is wrong. Yeah. So the trick will be, I believe, to have an agreed, or say a certified version of a golden test bench, where the ERA, for example, as the system authority said, this is it. This is the ETCS functionality. Yeah, and anybody not 100% complying with that needs to change something, because this is like the blueprint. This is how it should work. Yeah. So
yeah, of course, that is a very good approach here, and also this golden rule, or this harmonized, let's say, configuration, or how to say that should in the end reflect what is real in the field, or what will be used. So because if there would be differences in the infrastructure, in the track side, there of course naturally will interact with this golden test station, or with this golden laboratory where the test would have to be conducted. So the more differences between the lines, the more differences between the countries, the more effort for all the sides, for the lab, for the operator, for the supplier, because there is more things that have to be kept track on. And the harmonization, I think here is the most part, is the harmonization across the national level, where you have all the lines as similar as possible, but also on the European level, because still you may have these differences in implementation in certain countries. And when we talk about this interoperability, we need to have the unification to move smoothly from one country to the other, and not to risk that we will miss out something. Yeah. Eventually, if we want to run through the whole Europe, we would need to fulfill requirements maybe from 10 different countries. And I could imagine, I could not really imagine that right now, to run this whole track, for example, but because there's a lot of legacy systems as well there, and maybe ETCS is not rolled out in all the countries yet, but still to keep in mind that this is the goal, and we should think about that, how to achieve this, and step by step. So first, it should be done on the national level, just to make as much unified as possible, and of course, it should be harmonized on the European level, so that we don't need to do maybe authorization in 10 different countries separately based on different specifications, based on different approaches, because that would take a lot of time. And in my experience, we did authorization for the vehicles intended for many countries, like for 5 or 6 or 7. And this activities takes years, really, from the start, from the beginning of the project, from the development phase until when the system is ready, when it's already deployed on the, in the vehicle, until it gets really approved to be operated in these 5 or 6 countries. It's like it takes a lot of time, a lot of effort, a lot of retesting, and a lot of different people to be involved, and a lot of authorities as well, because you need to have this operation in 5 countries. So there's authorities from each country where they have to also prove that the system is correct based on different specifications. A lot of work, but I think it is something that can be reduced maybe in the future. And these examples that we showed here, I think, are the good base for taking under the consideration for the future.
I could imagine that test tools there could help a lot as well, because one benefit that you can have with a test tool that's smartly designed is that it automates certain test processes. So we had this before in my own experience, where if you had a new version of the software and you wanted to do a full-blown test, it took like 2 weeks. And then you had a problem on site, and then you said, well, we don't really have 2 weeks for every revision of the software. We need to bring it down to, say, something like 2 hours, or maybe 10 hours or something. So really reduce it not just by 5% or so, but really reduce it by a factor of 10 or a factor of 20. And automation was really the only way you can get it done. Also, if you have very, very many tests, if you have thousands of tests, or if you have, say, stress tests where several operators in an interlocking are basically doing operations all at the same time, and then the computer is flooded with inputs from all different kinds of sites. Automating this makes it much, much easier than trying to do this with like manual labor. Yeah. Bringing this to an end, I think what this discussion has shown, that testing is a very, very important activity to bring ETCS into operation. And I think that's a good career outlook for people like you who are involved in testing. So I don't really think you will have a lot of worry going forward in the future, because ETCS is still not just the flavor of the month, it's still the flavor of the decade, let's say. And the rollout plans in Europe are still going full steam ahead with ambitious plans to fit at least the Trans-European Core Network. So I wish you all the best for your further testing activities, and I would like to thank you for being available for this interview here on the podcast. Thank you for making the time.
Yeah, thank you very much, Frank, for this invitation. I really enjoyed the conversation with you, and I'm looking forward for the future episodes of your podcast, because it's fantastic. And I'm very grateful for your for approach for sharing the railway knowledge across the globe, actually, across the people who are also not involved in the railway engineering, because it makes things more understandable, and it's very important. Thank you very much, Frank.
Thank you. Thanks for the nice feedback. And I think it's an important point what you just said, and which is one of the purposes of these podcasts. So the hope is really to attract new people to the railway industry as well. There's so much talk about shortage of resources in our industry, and if this podcast contributes to bring a few new people from the outside into our industry, like yourself, I mean, you came from another industry, and you ended up doing a very fast fast improving and a very successful career. And if we can get this more often, then that's certainly a good thing to do. Well, to all our listeners, I hope you enjoyed this episode. And as usual, if you like it, then share it with your friends. Tell your friends about it. I don't think there can be enough Revit people that listen to this podcast. And I mean, if I had something like this at the beginning of my career, I would have I binge listen to it or binge watch it if you're on YouTube. So yeah, hope you enjoyed it, and there will be another episode next week. And as usual, keep it simple and bye for now.